Good day, dear students. Today we have lecture on discipline, information security and data protection. And today's topic will be about encryption of information using cryptographic algorithms of simple replacement. So, plan of our lecture consists from 3 questions: Zh.R encryption system, Zh.R affine substitution system, and Zh.R system with a keyword. Purpose of our lecture to form knowledge about the Zh.R encryption system. Introduction. Simple replacement substitution ciphers are among the earliest forms of cryptography, where each character in the plaintext is replaced with another character according to a defined rule. One of the most famous examples is the Zh.R cipher. These ciphers have been used throughout history to protect sensitive information from unauthorized access. Although they are relatively easy to break with modern techniques, they are essential for understanding the fundamentals of cryptography. Substitution ciphers teach critical concepts such as encryption keys, modular arithmetic, and letters frequency analysis, which are foundational in more advanced cryptographic systems. The first Zh.R encryption system. We have definition. The Zh.R cipher is a monoalphabetic substitution cipher where each letter in the plaintext is shifted a fixed number of positions down or up the alphabet. Formula: C is equal to P plus key mod 26, where C is the ciphertext character, P is the plaintext character, as a number from 0 to 25. Key is the shift key. Example: if the shift key is equal to 3 and we have plaintext hello, so ciphertext will be key H-O-O-R. Decryption: to decrypt, simply reverse the shift. P is equal to C minus K mod 26. Second question: Zh.R affine substitution system. Definition: an affine cipher is a more generalized form of the Zh.R cipher that uses a mathematical formula to perform the encryption. C is equal to A multiple to P and plus B mod 26, where A and B are keys of the cipher. A and B must be comprised with 26. P is the numerical representation of a letter. Example: keys A is 5 and B is 8. Encrypting A, P equal to 0 gives C equal to 5 multiple on 0 plus 8 and mod 26. So it's equal to 8 and it's consists from I. Decryption formula: P is equal to A in -1 degree and multiple to C minus B mod 26, where A in -1 degree is the modular inverse of modular 26. Third question about the Zh.R system with the keyword. A keyword Zh.R cipher replaces letters based on a rearranged alphabet formed by placing a keyword at the beginning, followed by the remaining unused letters of the alphabet. And steps: the first one, choose a keyword, for example key. Next step, create the cipher alphabet, for example key A, B, C, D, E, F, etc. Z. And next step, match each letter of the plaintext with the corresponding letter in the cipher alphabet. Example: keyword key, cipher alphabet, key A, B, C, D, etc. X, Z. Plaintext hello, and ciphertext letters are substituted according to the new alphabet. Conclusion: the Zh.R cipher and its variants are foundational concepts in classical cryptography. While simple, they introduce core ideas of substitution, modular arithmetic, and key-based encryption. Understanding these basic methods provides a stepping stone towards more complex cryptographic systems. Thank you very much for attention.